Okay, so for those of you who haven't taken the test, I'm going to reach out to you, but take it as soon as you can so that you don't fall too far behind. It is worth a good bit for sure. And if you do have any questions about it, let me know. I'm happy to help out. But generally speaking, just a quick review of everybody's performance. Looks like it was not so bad. Looks like you did well, felt prepared. Anything that you felt that you weren't unprepared for, let me kind of open the floor to that. I tried to make it stuff that we were doing in the review, try to correlate it pretty good to that so that you weren't surprised by the answers, or at least surprised by the process. Maybe the answers weren't something you like fractions, but at least the process to get there, hopefully you found was not too terrible. At least you felt that you were ready for it. Any,
Thank you. That was good.
any feedback? I mean, anything that you weren't prepared for? Let me throw it that way. Okay.
It's good.
Well, if you want to talk in private too, that's fine by me. Shoot me an email. Happy to help out. But
I thought it was going
do
to
you
be
have any?
harder.
Say it
Me
again.
too.
I thought it was going to be much harder than what it was. And then I started second guessing myself and going back over the questions because I was like, did I get this right?
Yeah.
Like maybe I missed
Yeah.
something, so it was
My
easier than
I
it
think we
style.
was.
all overthought it, you know? I
Yeah.
think we all just
Yeah.
overthought that it would have been harder than what it was.
Yeah.
Okay.
Because
It
Well,
was
they're messaging in
it
the
was
group me
fair.
going, that wasn't bad.
yeah. It's really to make sure that you have the skills. I'm not trying to kill you with it. I may throw in the next one. I may throw a hard one, but I have my choice. When I created it, I could choose from low, medium, or advanced. Difficult. And I think I maybe have one. I don't think I had any was difficult per se, because this is sort of the fundamental. I want to make sure that you know the process of everything, and then you know I'm getting used to creating tests in Hawks as well. So that was also I had a learning curve myself. So the next one I may throw one in there that's on the difficult side, but although it's difficult doesn't mean it's undoable. It just relies upon difficult probably means it tests multiple things at the same time. So that it's sort of one of those things. So kind of planning wise, I'm probably looking at your next test either probably in 2 to 3 weeks because I see that we're sort of falling behind on what we need to do. So we're going to have to pick up the pace a little bit. And there's opportunity for it. It's not like it's going to kill you, but I'm looking at the calendar. We're we're lagging a little bit, and a lot of that's me, by the way, because I'm a talker. So here's what we're going to do tonight. So I already see, and this is one of the sort of the things, because it's October 10th, and we're not ready for everything. So October 10th stuff, you just to kind of give you where you need to be. 6.R.1. What have we done? Let me put it that way. We have done 6.R.1, 3.R.4, and 1.2 and 1.3. Okay, so we have done those. So you should be working your way to completing those lessons. What are we going to do tonight? We're going to do 10.R.1 and we are going to do 10.R.2. The good news is they actually go together. The good news is that the special products of binomials, I'll tell you, focuses on the multiplication of binomials, and then the next one, 10.R.2, does the reverse process. So it's sort of they go hand in glove with one another. So once you see how the special products work, basically it's just an unwinding of that. It's a reverse process. So that's why they go hand in glove. And so by the end of tonight, we'll be done with those two that are boxed, meaning that we're really sort of lagging behind on this. But I'm gonna probably start with this one. Actually, I'm gonna do this one first, 3.0.5 and point 6, because you actually already know how to do it. Not because you know how to do trinomials, but because you know the grouping method. And these two, 3.R.5 and point 6, you can actually utilize the grouping method to factor those. So in a sense, we could probably do all four of those tonight real quick. I mean, not it's not an overload because it's just pattern building. It's doable, is what I'm saying. So that by the end of tonight, you'll be ready for the homework. You see, this is Sunday here. Is it Sunday? Yeah, the 13th. And so that'll give us sort of now we'll be not caught up, but we'll be really darn close to it. But this is all stuff that you know and can digest. You're ready for it. So let me do this. So let me go down to these first, and then we'll do that. So let me do this. I got to start up a program. Okay, so let me switch gears. Stop. Share. Okay, and let me make this big. This is my whiteboard, if you will. Okay, so one of the things, the 10.R.5, let me make sure on that. Nope. 3.R.5 and 3.R.6 deal with what we call trinomials. You'll see in the description, they do this: x squared plus bx squared, oh, sorry, bx plus c. And then the other one, 3.R.6, has just an a in front, ax squared. That's supposed to be an a, by the way. That's supposed to be an a plus b, oh, goodness. Yep. Plus bx plus, oops, plus c. These are what we call trinomials. Trinomials. Why? Because they have three terms. Trinomials. That's what they're called. Trinomials. Three terms. So that's the giveaway as to the process you're going to apply. Now, the thing to take note of here is that what's special about these, and the pattern is really based upon this notion of the values of the coefficients, the values of A, B, and C. So notice the difference between these two. What's the difference between these two? Does anybody see it? The value of A in the top one is 1. Okay, so when we call it the leading coefficient means the value in front of the term with the highest degree or the highest exponent. So here, the highest exponent is 2, so that's the leading term, and the value in front of that leading term is called the leading coefficient. When that leading coefficient is 1, factoring is one way. When that leading coefficient is anything other than 1, factoring proceeds along another way. So what I'm gonna do is when you see me type here, I'm gonna do something like this. I'm gonna use a caret symbol. That means the exponent of 2, so that I can type easier because my wrist is hurting, so it's not working too well tonight. Forgive me. Let me do this. Let me do this actually. I can actually type a lot easier. Okay. So we're gonna do stuff like this: x squared plus bx plus c. Okay. Or we're gonna do ax squared plus bx plus c. Okay. So here the thing is that leading coefficient is 1. So let's do stuff like this first. I'm gonna actually take that out. So let's work on examples like this, where the leading coefficient is 1. And that would be something like this: x squared plus 3x plus 1 plus 2. Okay, so we have three terms, and the leading coefficient is 1. Okay, so what you look at is in this scenario, step 1, write 2 sets of empty parentheses. Step 2, notice the x here is the leading part of it. That's the x squared is the very first term. So then write the variable as the first term in each parentheses. Okay, so let's do that here. So here we're going to write 2 sets of empty parentheses. Okay, and because we have it's x squared, we're going to put x as the first thing in each, just a plain old x. So the question is what we want to do, the goal, and I probably should have started with that. The goal in factoring trinomials, is to write it as the multiplication of 2 binomials. And when we say trinomials and binomials, we're talking about the number of terms. Tri meaning 3 terms, 1, 2, 3, and then bi meaning 2 two terms. That's what we're meaning. So we want something, so what we mean by that is something like x plus something, x plus something else, okay? That's what we're looking for, is the product of two binomials, x plus something, x plus something else. Now we could do minus, okay, so x minus something, x plus something. It doesn't have to be a plus. What we're looking for is two terms, parentheses with two terms. So that's what we're doing here. When your leading coefficient is a 1, okay, like it is here, it's an implied 1, this is the process. Write two sets of empty parentheses, write the variable as the first term in each parentheses, and then step 3, take the well, let me do it this way. Find the factors of the C value that add to the B value, okay? So this is our example here. This is our example here. So in this example here, what is the C value and what is the B value? And the way that you determine that is you basically you line it up. Notice the B value here, the 3 is in the spot for it, right? Whereas the C part of it is the 2, okay? So let me do a little subset of rules here. The B value is the value in front of the plain variable, okay? What do we mean by plain variable? Notice in the expression we have an x squared and an x. I mean plain x, plain variable, not the squared part. And the C value is the value without a variable. And so that's what C means. Constant means a constant. So no variable, okay? Cool on that? Because we'll do a couple more on these. Okay, so in this one here, now I'll break out my pen. What we want to do is this step here, this step 3 here says, find the factors of 2 that add to give us the 3. Find the factors of 2 that add to give us 3. So let's come over here to a scratch sheet of paper. Oh, excuse me, got an accent there. Scratch sheet of paper. Let's find the factors of 2. What does that mean to find the factors of 2? Find the values that multiply to give us 2. Remember, that's what factors are. They multiply to give us 2. And what are those values?
1 times 2.
1 times 2. Now, when we do this process, you want to find both the positive and the negative factors. Okay, so what are the negative factors that give us 2? And the way that you do that is you just change the sign. -1 times -2. I want you to get in the habit of that, okay? Now, why am I, let me step back, and I forgot to mention, why am I choosing the value 2? How do I know it's positive? How do I know I should be dealing with positive 2? Because I have a plus sign in front. I'm just setting you up for another example, but I want you to just keep in mind the plus or minus in front is attached to it as the sign, positive or negative. Okay, so we find the factors of 2, 1 times 2, that's it, or -1 times -2, and then you add them, okay? So let's go ahead, oops. So let's add them now, and that gives us 3. And we add this one, and that gives us -3. So we want to choose the pair of factors that add to give the middle value, which is 3 in this case. So the pair of factors we're going to pick is going to be the values 1 and 2. So that's what we put over here in the parentheses. That's what we put over here. So we write then, this becomes x, okay, remember what I have, x in each spot, and I write 1 and 2, but keep in mind the sign, +1, +2, +1, +2. That's the factoring. Two sets of empty parentheses, put the variable, in this case x, first, find the factors of the c value, and then see which pair of factors adds to give you the middle value, the b value. That's the process. So we're going to do another one, and we're going to start looking at different signs, but that's the general process. So let me pause here. How are you feeling on that?
So what was the purpose of doing the -1 and -2?
For the next example.
Okay.
I'm setting you up. I want you to never forget positives and negatives. Never forget. It's one of those things. And I don't want you to be surprised because it's coming. So here it goes. So let's do another one. This time I want to do -3. Okay. And so it very much is. So we still have the same value of C. Notice we still have the same value of C. I wonder if I can do that. Here we go. So let's take this off. So notice I still have the same value of C, but the B value has changed. Now I want the sum that adds to -3. That's why now we choose this one, because it adds to -3. So in there, we would put -1, -2. -1, -2. So I want you to get in the habit, when you do factoring, think of the positive factors and the negative factors. It'll become more obvious in a moment why we do that, but you just gotta, it's one of those things of positive and negatives. We love to do it. This is one of those areas. Okay, so that's the general process. 2 sets of empty parentheses, variable in the first spot, take the C value, find its pairs of factors, both positive and negative pairs, and then see which pair adds to the middle value of B. Now it's time for a wholly different example so that you can see the process. So this time I'm going to do plus 5 minus 6 plus 5x. Okay, so let me do y. Let me change it up. So y squared plus 5y minus 6. Okay, so what do I do? Okay, I was doing that. 2 sets of empty parentheses. This time I use the variable y. Okay, and now what do I do? Take the value. What value am I going to take as my c value?
-6.
-6. Okay. So what are the factors of negative? What numbers will multiply to give -6?
2 times -3.
2 times -3 is one of them. One pair. What is another pair?
3 times -2.
-1 and 6.
So what I do, so we can see we're all over the place. Okay. So here's what I do. Always start with +1. 1 times what?
So -6.
-6. 2 times what? -3. And just keep going. Get all your start off this side of it with +1, +2, and then string it all out, whatever it's going to be. Okay. So that's it for this one. Then once you got all the +1, +1, +2, then just flip the signs, move the signs over. Now it becomes -1 times +6. So you've already got them listed. So now you just transfer over the minus sign. If you want a methodology, that's my point of this. It's not that you have to do it. It's just how you got to keep track of it sometimes. For larger numbers like 24, 32, there's a lot of factors. And so you need a methodology to keep it track. So I just start with +1, +2, +3, and kind of just work my list. Once I've got them all, then I just create recopy the list, transferring over the minus sign. Okay, so at this point now, this is when we do the add. So we add them now. Add them. And so when we add, which one adds to give me +5? So this is -5. This is -1. This is +5. And this is +1. So the winner is this one. Why is this one the winner? Because my B value is a positive 5. Do y'all see that?
Mhm.
So then I come over here and I add in my values. I have a y and a y. So what are my factors? -1, +6. -1, +6. And talk to yourself like that because it tells you what the sign is going to be in the middle. So this is the factoring, y minus 1, y plus 6. And by the way, you could also write this as y plus 6. You can switch the order. It's fine. They're both the same. How's that feel? So I'm going to give you one to do on your own. Try it out. Give you at least allow you an opportunity to get started with it. So let me do y minus 12y plus 32. Y minus 12y plus 32. So get started with it. I'll give you 30 seconds. You're not going to finish it, but just give you a shot. Okay, so what are the factors of 32? 1 times 32? Now, I'm doing positive 32, by the way, right? Because my C value is a positive 32. So I want the factors of positive 32. So 1 times 32, 2 times 16, 3, no. 4 times 8, 5 times, no. 6 times, no. That's it. I'm done. That's all my positive factors. Okay. So I also then want to incorporate the negative factors. So -1 times -32, -2 times -16, -4 times -8. So now you want to see which which pair of factors will add to give you the middle value. What's the B value?
-12. So you
-12,
would add -4 and -8.
right. Oh, there's a 12, but that's not the right sign. So once I see that, by the way, I'm pretty much going to skip to the end and say, oh, I know which one it is now. It has to be that one. So these are the pairs of factors, -4, -8. So when I go to do it, that's what I'm going to write, -4, -8. And that's it. This may seem not quite consistent with what you learned previously and how you learned it, but there's a reason why I'm doing it this way. It's because we're about to change this number here from 1 to something else, but it's the exact same process. So that's why I want you to get into this mindset of positive and negative factors. It really helps for when we amp it up a little bit. Questions on this? In a lot of ways, I find this is easier than the GCF factoring, that we did previously. A little less work, but you still need to be prepared to find the GCF as well. So with that in mind, let's take this now, and that's pretty much it. The only way we can really jazz this up a little more is, let's suppose, if I wanted to make this challenging, is let's suppose I did something like this. This is the new problem right here. This looks difficult, huh? There's a lot to it. There's X's and Y's and all that stuff. So when you come across a problem like this, ask yourself, hey, can I take out a common factor? Is there a GCF? Is there a GCF? And you're like, well, wait a minute. They each have X's, don't they? Here's an X here, there's an X here, and there's an X here. So yes, there's something common. And also I notice, look, the values themselves, 2, 24, and 64, those are even. Yeah, there's a GCF there. There's a common factor. So when you have something like this, what you would do is take out the GCF first. The GCF in this case being 2x, okay? Then you would factor the middle, the trinomial in front, the trinomial in front. So that GCF just hanging out there in front, you just bring it down. But notice that by taking out the GCF, we turned it into something that's a lot easier to factor. So my point is that when you approach a complex problem like this, ask yourself, is there a common factor I could take out? Because if there is, go ahead and factor it out, and the result may be easier to factor afterwards. One more that I forgot to show you before we move on. Suppose I have something like this. X squared minus 2x plus 4? Yeah, we'll do that, plus 4. That's supposed to be a 2, by the way. It's not a real good 2. Let's go through our process. Empty parentheses, xx. What factors of positive 4 will add to give negative 2? Well, what are the factors of 4? 1 and 4, 2 and 2, negative 1, negative 4, oops, and then negative 2 times negative 2. Which of these factors, pairs of factors, add to give us the negative 2?
The negative 2 plus, you have to turn it to a plus negative 2.
Well, do these add to give negative 2?
Well, don't we have to put an addition sign in the middle?
Mm-hmm. So that's why we write them as pairs, and then we add them to see which pair gives us the middle value of negative 2.
So that would be the bottom, right?
Negative 2 plus negative 2 is what? Negative 4, not
Oh,
negative 2.
okay. Right, we're adding it. Okay.
This is what we call a trick question. So I set you up. Sorry, Jana.
That's okay.
You fell into the
That's
trap.
okay.
So what's the trap here? None of them add to give negative 2.
Okay.
So that's it. There's nothing that works. So because nothing works, we call this prime. It's a prime polynomial. There is no factoring you can do of it. Just like prime numbers, 2, 3, 5, 7, the only factors are itself and 1. And that's the only thing. So this is a prime polynomial. It can't factor. So sometimes that happens. They're going to throw that at you in the homework. I promise you. So if nothing works, if you find the factors of that C term and none of these add to give you the B value, it's prime. Cool? It's just you got to get all the examples down, but the process remains the same. So what you want to focus on really, I hope one of the takeaways is focus on the process. When your leading coefficient is 1, this is your process. A leading coefficient of a trinomial. This is your process. You're focusing on the factors of the C value that add to give you the B value in the middle. Okay? Questions on that? So we're going to change it up a little bit now. We're going to change it up a little bit. Let me erase this. Let me erase this. This time what we're going to do is we're going to do something other than 1. Okay? Something other than 1. How does it change this process here? Not a whole lot. Not a whole lot. I'm going to change this up right here. It's step number 2 that changes. Okay, part of it. So write 2 sets of empty parentheses still, because that's the goal. We're trying to get the multiplication of 2 binomials. Instead of step 2, now we've got to change it up. Multiply the A value with the C value. Okay? Multiply the A value with the C value. We call this, with every lack of imagination that mathematicians have, the AC value. Okay? A times C, AC. Okay? So what you do is you
We got air conditioning now?
Yeah,
Sorry.
yeah, we need it, huh? So find the factors of the AC value that add to give the B value. Okay, so I'm going to add one more thing here. The A value is the value in front of the x, the x squared or the y squared term. This process, we call it the AC method. You can use when the leading coefficient's 1 as well. It's longer, more difficult, it's unnecessary, but it still works. So this is a general process. So write 2 sets of empty parentheses, multiply the A and the C values, find the factors of the AC value that add to give to the middle B value. That's the process. It's almost identical. Well, this is sort of it. I'm going to have to add one thing. This is really it. Hold on. Find the factors of the AC value. We do this. Oh, yeah. There is a fourth step. That's right. I forgot about that. Rewrite the B value as the sum of the factors of AC. Then apply the grouping method. Okay. It's the grouping method that's the key here. I want to remind you and refresh your memory and ask you a question, see if you remember. How many terms does it, in order to apply the grouping method, how many terms must your polynomial have? Does anybody remember?
4.
But wait a minute, I only have 3. So what the whole purpose of this method here is to break the middle value, the middle term, break it up into 2 terms. Okay, so that we can apply our grouping method. That's the point of this. That's why we do this one right here. Is take A and C, multiply it so you can break it up into those 2 terms, and that allows you to do the grouping method. So let me get my scratch sheet of paper and let me do one. So got it. Okay, 6x squared plus 17x plus 5. So it really depends upon, you need to know the values of how to find A, B, and C. A is in front of the x squared, B is in front of the x, C is the one without a variable. So in this case, so we still write 2 sets of empty parentheses, okay? So that doesn't change, okay? So we're still going to do that. But we're going to have an intermediate step. Well, maybe we don't need to do that. We can wait. Okay, so take the value of A and C, okay? So I'm going to come over here. The value of A and the value of C. Multiply them. That's what step 2 says right there. Multiply them. And multiply 6 times 5 to get what? 30? Then find the factors of that AC value. Find the factors of 30, okay? So 1 times 30, 2 times 15, 3 times 10, 5 times 6, yeah, of course. And then we have the negatives too. And then we have the negatives. So I'm going to write it over here. -1 times -30. As you get more proficient with factoring, you can save yourself some work. You don't have to do this all the time. Once you feel confident with it, done some practice, I probably would have shortened my work by this point. Because there's certain things that I can see that are not going to be it. But for completeness sake, let's write them all out. So these are the factors over here and then over here. So we do the same thing. We find which pair of factors will add to give the middle value of positive 17. Which one does it? Which pair of factors does that?
2 times 15. Positive 2 times positive 15.
I love it. Love it. Love the positive. Great. Yep, that's the one. Positive 2 plus positive 15. So we're going to break this 17 up. Positive 2, positive 15. Now it's 17x, 2x, 15x. That's the process. So we're going to break this up now. And so when I break it up, by the way, it's going to all go away, but it'll be there. I'll bring it back. So this becomes 6x squared plus 2x plus 15x plus 5. This middle part here was from the 17. I just broke it up into 2x plus 15x. Now notice I have 4 terms. That's why I can apply the grouping method. And so that's what you do. Put your parentheses around the first 2 terms. Put your parentheses around the last 2 terms. Pull out the GCF from the first 2, which is 2x, leaving us 3x plus 1. Pull out the GCF from the second one, which is a 5 in this case. Oops. And keep in mind your self-check. You're looking to make sure that you have the same binomial in the parentheses. If you don't, go back and check. You probably got a mistake somewhere. Sign error, factoring error, who knows. So now we have the common binomial, 3x plus 1. We pull it out. And what goes in the middle? What goes in the middle? Well, you would say what? The stuff that's in front of the parentheses. 2x and then plus 5. And there it is. That's the answer. That's factoring trinomials. Take the AC term, multiply to get the AC value. Find the factors of that AC that add to give you the B value. Break up the B term into 2 so that you have 4 now, and then apply the grouping method. So let's change it up. Let me give you...
Well, I have one question. Okay, so I guess I was writing and trying to pay attention at the same time. So when you got the answer, because we separated it, the first one was 3x plus 1. And so why did we pick the 2x plus 5?
Well, that's the stuff in front. Remember the other day, one of the things we did in the grouping method is when you have this common binomial and you pull it out. Remember that, imagine it, you're pulling the 3x plus 1 away. So when you pull 3x plus 1 away, what's left behind? The 2x in front.
Okay.
And then the same thing here. You're pulling it out. That's what factoring is. You're pulling it out. So when you pull it out from that term, you're left with the plus 5 goes away. So think of it kind of like a void.
Okay.
It's a void. That's what's left when you pull it out.
Okay.
Mm-hmm. let me do another one here. Oop. Oops. I almost gave away the answer. 8y squared. This one, hold on. Let me tweak it. I don't like that. Okay, that's fine by me. So 4y squared minus 25y minus 21. First step, multiply your a and your c. So what is my a value?
Is there an A value?
That's
I
a
don't
good
see
question.
it.
What is how do we find the a value?
Oh, shoot. I don't know.
It's 4.
That's fine.
It's 4.
The a value is the one in front of the squared part.
Okay.
And so here our squared part is 4. It is y squared, so we look at the 4. This then where our work here, by the way, is going to help you immensely when we go do what we call quadratics, because it's all the same thing. Okay, so Addie, does that help with the a value? Okay, good.
Yeah.
Okay,
So
so
we're doing 4 times negative 21?
yes, 4 times negative 21. So the a value is 4. The c value, was that Jackie? Negative
Yes.
21. Remember, attach that minus sign, the negative 21. Very important.
You get
Okay,
negative 84.
so we're going to come over here, our scratch sheet of paper. It is indeed negative 84. That's the AC. So we got this by doing 4 times negative 21. That was the A, and that was the C value. Okay, we multiplied to give us negative 84. Now we find the pairs of factors of negative 84. Oh, thank God. Okay. I didn't make a mistake. So start off with positive 1. You just kind of go through the process. Positive 1 times what?
Negative 84.
Negative 84. Boom. Does 2 go into 84? I'm sorry, negative 84?
Yes.
How do we know that, by the way?
Because it ends with ends with an even number.
Even number, exactly right. So work your calculator and we get
42.
negative 42. Does 3 go into 84? No
Yes.
idea. So I'm going to do my calculator because I can't do that in my head.
Well, I thought if you add the 2 and you get a sum, which is 12, then and it goes into 3, then it should go into 3.
Did I tell y'all that rule?
I learned it
I
somewhere.
don't think I told you. I have gone through that with one other classes I taught. I don't think I told you all that rule. So if I could give you a gold star, Jana, or a bonus points, that is right.
Yeah,
A lot of
I
people
think I
don't.
read all the rules and I just remembered that.
A lot of people don't know that rule because it's sort of
Yeah,
obscure and it's
and
weird. So if you didn't know that rule, that is okay. I didn't tell you that. Just take your 84 and divide it by 3. If it comes up with a nice pretty number, you're in good shape.
yeah, I've said the rule before,
Okay.
so
Awesome. Yeah, so for those of you who didn't know the rule, look at the 8 and the 4, add those digits, and if the sum of those digits is divisible by 3, then the whole thing, 84, is also divisible by 3. All right, so what about 4? Yeah, 4 is, I can see it. It's 21. 5? No. How do we know that 5 doesn't go into 84?
It doesn't end in a 0 or a 5.
Or a 5, right. 6? I don't know. I don't think so. Oh, it does? So I was
Yes.
wrong. Oops, I was wrong.
6 and negative 14.
Okay, how about 7? I don't think so, but I'll try it.
12. Wow.
12. Oh my goodness. Don't count
Oh
on
my
me.
God.
Yeah, the way you figure out 6 is if it's divisible by 2, and if it's divisible by 3, then it's a very high likely
Right.
chance that it's divisible by 6.
That is a great point. So then 8 I know, not it. 9 I know, not it. 10, 11. So we're good. This is it. And so now let's do the other set of factors. I'm going to change my coloring. So then just switch your negative over. And by the way, you can probably start seeing which one is the one we need to hone in on. So what are we're looking for which pair at what's our B value? Let me say that. What's our B value?
25.
Negative 25.
So
Negative 25.
which pair is going to add to give us negative 25?
Three times negative 28.
Boom. This one right here. That's exactly right. So we're going to break this negative 25 up into positive 3, y plus or minus. Minus 28y. That's what we're going to do. Break it up into two terms. So I'm going to do that. I'm going to take, this is all going to go away just to let you know. But that's the goal. We break up that middle term into two terms. So here we go. So 4y squared plus 3y minus 28y minus 21. Now I apply the grouping method. Remember, I put parentheses around the first two terms, parentheses around the last two terms. Is there anything in particular I need to keep in mind when I do this? When your middle sign is a minus,
Turn the
and
last two.
parentheses, what do you have to do?
Turn into positive.
Change the sign in front of the last term, change it from minus, in this case, change it to plus. Just change the sign.
Okay.
That was that special thing we learned the other day.
Could you
Now,
say that one more time? I'm sorry.
now notice here, in these last two terms, there's a minus in front of that 28y. So when I put the parentheses, I slice it. I put that parentheses, I separate them. Okay? The minus sign was connected to that 28. I sliced it off. I cut his arm off. When I do that, you got to change the sign of that last term. So this parentheses right here, between the minus and the 28, requires me to change the sign here, this last one, from a minus 21 to a positive 21. Just change that sign of the last value.
Okay, thank you.
Now you take the GCF out. So in this one, for the first parentheses, the GCF is just a plain y. Bring down the minus. What's the GCF in this last set of parentheses? I wrote, sorry. Okay. I thought I heard it. 28. So then it becomes 4y plus 3. Do yourself a self-check. Are the binomials in the parentheses the same? Yes. So it means we're doing good. So bring down that common binomial. And in the second empty parentheses, you put the stuff that is on the outside, the y and the minus 7. You're pulling that 4y plus 3 out. Pull it. So what's left behind is that y minus 7. And there it is. Questions on that? By the way, you can check your answer. Check your answer. Okay, so we're going to talk about that process because that rolls into the next thing that we have to do. But
I do have a question. Okay, so the second to last step, when we got the common factors, I'm trying to figure out. So is y 4y to the second power. Why did we leave the square off of the y?
Because we pulled from this one, what's the common factor?
Y.
What do they have in common? So I pulled one y out,
Okay.
a single y. So if you pull a single y from the y squared, remember, y squared means what? Two y's. So
Right.
if you pull one of them, you only got one left.
Okay.
That's why we have one y.
Okay. So how did it? I guess I missed that. So how did the y get on the outside? So you put okay. So that was the common one.
That's the GCF for this
Okay.
particular parentheses.
Okay. So then you put plus, and you took the y off minus, and then the 7 was the GCF. So 4y. Okay. I think I got it now.
It's like having three Y's,
I got it.
In a sense.
and you just taking one of them out. Yeah.
Mm-hmm.
Okay.
So you can check your work, by the way. You don't need me. I'm giving you ways to just not have to be your to not need me anymore. Let's go back. Suppose I have this. Just go back in time a little bit to test 1. If I wanted to get rid of the parentheses, how would I do that?
Distribute.
Distribute. I take that
-7 to everything
-7
inside.
and multiply it inside, and this would give me negative 28y minus 21. But that's not what I want to show you. That's not all of it. That's not all of it. What I want to do is I want to check my work here. How do I do that? Well, the way that you do it is basically just is this. Every term here is going to get its own copy of y minus 7. Going to get its own copy of y minus 7. Well, what does that mean? Well, take the 4y and give it its own copy of y minus 7 plus 3 times y minus 7. So every term of the first binomial, the 4y and the 3, is multiplied with its own copy of y minus 7. In essence, we distributed the y minus 7 inside, but I like my way of saying it better. Every term in the first parentheses multiplies its own copy of the second parentheses. 4y is multiplied to y minus 7, plus 3 is multiplied. Now we do the same thing, don't we? Where'd it go? There it is. Okay. So now we do like we did on test 1. Take the 4y and multiply it to each thing in its parentheses. Take the 3 and multiply it in its parentheses. And what does that give? 4y times y plus 4y. Oops. Well, doesn't like me. There we go. 4y times negative 7 plus 3 times y. I'm going to go ahead and multiply that minus 3 times 7. And then do the multiplication. So you really, to check your work is really just applying the distributive property. That's all it is. So 4y times y gives us, I did it again.
4y squared.
What did I do? Okay, well, you know what? It's all going to go away now. So, it doesn't like me, so I'm going to punish it. So this is what we're doing. Now multiply should be this. Sorry. So now we do the multiplication. 4y times y is 4y squared. 4y times negative 7 is negative 28y plus 3y, then minus 21. Now combine your like terms in the middle, which is 25 minus 25y minus 21. Look at that. Oops. This is the exact same thing we got up there. So this is the process for checking your work. Just take each term of the first parentheses and multiply with its own copy of the second parentheses. We're going to do this again for the other lesson too. But when you do that multiplication, what you get as the product should be what you started with at the very front end. So that's how you can check your work as well. And notice this right here, this is why we learned the rules of exponents. Because to multiply 4y times y requires the product rule. Multiply the same base, add the exponents. So the y times y, that's how we got the y squared. Just as a reminder. So we've done a lot so far. We've seen the process for factoring trinomials when the leading coefficient is 1 and when the leading coefficient is not 1. We've also seen how to check your work, multiplying the binomials. We're going to do this, we're going to do some review on this too. So let me give you a quick side note. The homework that is coming due for Sunday, if you get it done on Monday, that's fine too. I'm not going to, hold you to it. Work to get it done on Sunday as best you can, but we're going to review some of this on Monday as well. Because it's a lot we're sort of going over all at once, but it's all sort of connected, and it's really just taking old stuff that you know and putting it all together. Factoring is really much a mashup process, taking all that stuff that you did on test 1, if you will, with polynomials, distributive property, like terms, and then rules of exponents, and we're putting it all together. So let me step back. Questions on the process, the AC method for factoring trinomials when the leading coefficient is something other than 1, like this. Any questions on that? Multiply your A and C, find the factors of A and C that add to the B, rewrite the B as 2 separate terms, and then apply the grouping method. Just gonna take a little practice. Any questions on this part about checking your answer? So let's pick this up. We're going to start with this because now let me kind of go back to share. Okay. So what we're going to do now is we're going to pick up. Where'd it go? Oh, this. Oh, yeah. Special products of binomials and then special techniques for factoring. They go hand in glove. They're virtually the same thing. They're just reverse processes of each other. So let's take a look at the special products of binomials. And I think you're going to like this because it really does boil down to a recipe, a pattern, if you will. So let me go back here and do this. Okay, and I'm going to do this now. Share. We get a new blank sheet of paper. Okay, what I want to do, let's do this. I'll give you an example. Let's build upon this sort of checking procedure, but this time what I'm going to do is do something like this. Let me take x minus 1 times x. You know what? Let me do this instead. X plus 1 times x plus 1. Or, well, I'll just keep it at that. What you want to do, the process of what we're doing is we're multiply the binomials. Okay, multiply the binomials. The direction will say multiply. Multiply the two, multiply the polynomials, multiply the binomials. They may phrase it in a couple different ways, but multiply is what we're doing. So how do we go through this multiplication process? Well, every term in the first parentheses is going to be multiplying its own copy of the second parentheses. Okay? So let's do that. What does that look like? Bear with me. So I take the x and I multiply with its own copy of x plus 1. And then plus 1 times its own copy of x plus 1. Okay? Cool so far? All right. Now Do your distributive property. X times X is, what would you say?
X squared.
Boom. Exactly. X squared. X times plus 1 is what?
1x. Or just x.
Yeah, 1x or plain x, whichever way you want. I don't mind. Plus 1 times x,
X.
another x, and then plus 1 times 1,
1.
1. Combine the like terms. What are our like terms?
X and x.
X and x in the middle to give us what?
X squared.
Yeah, so what do these two like terms combine to give?
X squared. Oh, just kidding.
When you add,
2x?
yeah. Yeah, so you're flipping two rules now. So yeah, quite common. You got a lot of rules spinning.
Right.
Combining like terms, you add the coefficients in the front. So 1x plus 1x gives us 2x's. And then just bring everything else down. So I wanted to start off with this one first to show you you can just multiply them the way that you would to check your answer for factoring. It's the same process, okay? Multiplying polynomials is the reverse process of factoring. Remember, factoring is breaking things apart, multiplying is bringing them back together. Okay, so we're working in reverse process. So let me pause here. Any questions on this?
I have a question.
Uh-huh.
Can you put your 2x that's in the middle, you can't put it with your exponent because they're not the same because the exponent, right?
That is correct.
Okay, I was just double checking.
Let me do another one. Similar. I won't use ones. I mean, we could, but I'll give you a break. Yeah, Carmen, go ahead. Okay, so let's do this one. X minus 2 times x plus 2. Same process, okay? We're multiplying, we want to multiply them, okay? So take your x and give it its own copy, multiply its own copy with x plus 2. And then take your second term, second value of minus 2, okay? It's important, minus 2, times its own copy of x plus 2. And then apply the distributive property. X times x, so x times x is x squared. X times plus 2 is plus 2x. Minus 2x times x is minus 2x. And then minus 2 times plus 2 is minus 4. And in this particular case, notice, what do the like terms add to give?
0.
0. They go away. So we're just left with x squared minus 4. I'm not teaching you anything. I'm not showing you anything new. What I want to show you is that you can apply your process for multiplying binomials. That doesn't change. But what I'm going to show you is that there's another way to do these exact two same problems. They follow a pattern. But if you forget the pattern or don't like the pattern, that's okay. You can still apply this process. That's what I want to kind of get you to, okay? Any
So,
questions on this process for multiplying?
so we are multiplying the second parentheses first.
You take every term and kind of watch the recording again and listen to the way I'm saying it and repeat it back when you talk to yourself later.
Okay.
Every term of the first parentheses multiplied with its own copy of the second parentheses. So every term of the first, so x got its own x plus 2, and minus 2 got its own copy of x plus 2. Every term of the first parentheses with multiplies the second parentheses. By the way, you know this as a word. You know this as another process.
Okay.
Does anybody know what the process is? I'm not hiding it. I just don't like it, but that's just a preference me. What's the this is a longer version of what? Foil.
Forty.
You probably know foil, right? First, outer, inner, last. That's foil would get you this line, would skip you. Oh, whoops. If you did foil, you would skip ahead to this. Why don't I use foil? It's easy. We know it already because foil is very specific to only one kind of problem. What I'm showing you here works for every problem. Anytime you need to multiply polynomial. So what if you have a trinomial times a trinomial? 3 terms times 3 terms. FOIL doesn't work in that case. So you take every term of the first parentheses, multiply it with its own copy of the second parentheses. But if you like FOIL, FOIL away. Just recognize and be aware, FOIL only applies when you multiply 2 binomials. Only 2 binomials. That's it. But if you have 2 binomials like you do here, FOIL is the magic elixir.
So we don't have to do FOIL. Like that's just another step we got to memorize.
Yeah, if you know what FOIL is already, go with it. And if you like it, go with it. If you don't know FOIL and you've never heard of it before or don't care for it, don't worry about FOIL. Eject it. Scratch it out of your notes. Uh, did y'all ever see the movie? I'm kind of old now, but Memento with Guy Pearce and I forget, Carrie someone. She was in the Matrix. Anyways, he had memory problems, and he got to the end of the movie, and you saw that he would change his memory by scratching something out. He forgot it because he had memory problems. So he said, I'm going to make it so I don't remember things." So, anyways, if you don't like foil, be Guy Pearce and erase it. Anyways, but I showed you this one so that when you do factoring, this is the process you can apply to check your answer, whether you're right or wrong. Okay, it helps with that. Also, this process here, you can use it in that 10.R.5 for multiplying special binomials. Okay, so you don't have to learn anything new. But let's talk about the special binomials. What do we mean by that? And these two problems represent the special binomials. There's a pattern that builds out. So I'm going to take each one of them separately to show you what that pattern is, so that you can have an alternative method. And this is what you're going to see in Hawks on this. So here goes. So this very first one that we did, I did x plus 1, x plus 1 times x plus 1. Now, you're not going to see it like this in Hawks, by the way. How are you going to see it in Hawks? No, it won't do it. You're going to see it like this. X plus 1 to the second power. And we know, what we're doing is we're combining our ideas of polynomials and exponents. What does it mean? This means 2 copies of the base. 2 copies of the base. So x plus 1 squared is the exact same thing as saying x plus 1 times x plus 1. Okay, so I just want you to be aware of that the exponent stuff that we learned all the way back a long time ago still applies even with binomials. And that references, again, something I've said before, just reminding you don't have to remember it. You learn the rules for add, subtract, multiply, divide numbers. You learn the rules for add, subtract, multiply, divide decimals. Add, subtract, multiply, divide fractions. And what we're doing here is going over the rules and showing you add, subtract, multiply, divide variables, polynomials. We're just redoing the process. So we're taking all your old stuff and mashing it together. I got someone behind me. Anyways, I just want you to recognize that this exponent of 2 really does mean the same thing that we've always thought of. Now, the way that they're going to illustrate this for you is that there's a pattern. Okay, so here's the pattern. let's talk. Let me write the pattern out first. When you have the exponent of 2, okay? Let me write the pattern. Let me write it generally over here. You're gonna write it. You're gonna see it like this.
Do you have any white paper?
No, go downstairs. Hold on, bud. Hold on, bud.
Okay.
It's a binomial. So you have a first term of a binomial, and you have a last term of the binomial, and it's squared. So the pattern is what? What happened over here? What was this one? Let me go over here. Remember what this answer was over here? X squared plus 2x plus 1. Okay, that was the answer. We just did it a minute ago. So how does that apply over here? Well, you take the first term, it's just a recipe. Square the first value, take the first value and the last value and multiply it by 2, and then add the square of the last term. Okay? That's one pattern. We have a second pattern, very similar. It's if there's a minus sign in front, in between. F minus L squared. It's the same thing. The only difference will be this sign right here. It's exactly identical. It's just that sign in the middle. It'll be the first term squared minus 2 times first times last plus the last term squared. That's the second pattern. So a binomial squared, first term squared plus 2 times the first and last plus last term squared. Okay. With that in mind, let me do an example. I'm running out of colors. I'll do this color right here. Okay, so let me do 3y minus 2 squared. Here's the pattern. All you have to do is recognize what's your f and what's your L. So this is your first term. This is your last term. The minus 2 is your last term, okay? Okay, so first term squared plus, well, we could do the minus, so 2 times 3y let me write it, there we go, times 2, and then plus the last term squared. And then do your multiplication. 3y squared becomes what? What's 3y squared? Or 3y times 3y? So 3 squared is 9. Y squared is y squared. Negative 2, so now the middle one. Minus 2 times 3y times minus 2 gives us minus 12y. And then plus 2 squared is 4. And that's it. And that's it. Not too bad, huh? It's just following the pattern. If you see it's f plus L squared or f minus L squared, just find your first, identify your f, your first value, your L, your last value, and then follow the pattern. This is the pattern, is what I'm talking about. Go for it, Addie. Yeah.
Yeah, so the formula is f squared. Okay, so you have like f squared minus 2 times f times, like 2f times L.
Mm-hmm.
So would it be, I'm just a little confused because it's 3y squared minus 2 times. Okay, never mind. I thought we'd missed the minus. Sorry, I'm just kind of my brains.
Which minus?
Um, since there's a minus 2 in the first set of parentheses,
Mm-hmm.
I was wondering where it went, but then
Yeah, it's right here.
got it. Yeah.
Happens to be right there. It happens to be lined up.
Sorry, yeah, I just missed it.
That's good. No. So we're gonna do another one now. We're gonna do the other pattern. We're gonna do the other pattern.
There's another.
There is another one. It's not a terrible pattern. You'll like it. So the other one, that's called the perfect square trinomial. Perfect square. Okay. The name's not important. What you want to look for is the binomial squared. Okay. This one is called the difference of two squares. I'll write that one out. The difference of two squares. Okay. What does this look like? Maybe this is easier if I type it. Oh, wait, let me do it this way. Let me actually type it then. The difference of two squares. Okay. What does this look like? The word difference means subtraction. So, so it's f plus L, f minus L. Okay. Gives us f squared minus L squared. Okay. So if I have, is that me?
No, that was my watch. I apologize.
Awesome. So remember what I did. X minus 2, x minus 2, or x plus 2. Okay, remember that example? We went through the multiplication and we found our answer was x minus 4. Okay? We can find that process here using our pattern. Okay? What's the f? It's x. F is the first term in each. Okay? So we say x squared minus, what's the L? It's the 2. Notice it's the same, it's just different in sign. So then we say 2 squared. So now do the squaring, x squared minus 4. It's all about matching the pattern, the position, if you will. Okay? So with that in mind, let me give you one to do on your own. Or let's see another one. Y minus 4, y plus 4. Okay? What's the f part in this one?
It'd be Y.
It would be y. So we're going to say, so doing f squared minus L squared, we say y squared. And what's the L part?
4.
4 squared. And then you just simplify the squares. Y squared minus 16. So it's sort of a shortcut. You don't have to do you can do the multiplication if you want, but this is a shortcut. So let me give you another one then. Okay, what's the f here? And 5m plus 3 times 5m minus 3.
5m.
So we say f squared 5m squared. So notice I'm going to multiply, I'm going to square the entire 5m minus, what's my L?
-3.
Just the 3 part.
Oh.
Because remember, the pattern is this. F and L. And so we choose the L to be, in this one, it is weird. It goes against everything I said, doesn't it? We don't look at the sign in front. We just look at the number part because we're building the pattern to sort of incorporate the minus sign already. So you just look at the number part. And that's why we're just doing the 3.
Is there a reason why we're putting the 5m in parentheses?
Because we want to make sure we square both the 5 and the m. We could put the 3 in parentheses too if we want.
Okay.
But the reason I did it for the 5m is because there's two parts. There's a 5 and an m. I want to make sure I square both values. So on that note, when I do 5m squared, what does that give me?
25M.
Yes, exactly. Okay, I'm gonna write it out. 25m what? Squared. Because the 5 is squared, so 5 times 5 is 25, and then we have m squared too. So that's, you don't want to forget that. Minus 3 squared is 9. And that's the answer right here.
So you're just putting not like you're putting it squared again because you don't have to apply it to the 25 again.
No,
You're just applying it still to the
the square is only now affecting the m.
Okay.
And remember, this goes back to our power rule. 5m squared. Remember the power rule says take that square and apply it to each one inside. So 5 squared and m squared.
Mm-hmm.
That's how we get 25 m squared. Now, these patterns, they work this way. Notice I'm showing you, hey, if you got f plus L, f minus L, and by the way, it's the same thing. It's the same thing if the first one was minus and the second one was plus. It doesn't matter. So what we're saying is look, if you've got the same thing in both binomials, but just different middle sign, that's what the pattern is. The difference of two squares is it becomes f squared minus L squared, okay? The cool part, and so this is section, which one? 10.R.2. 10.R.2. That's this way. You got these two binomials and you're multiplying them out by way of this special pattern. 10.R.3 is the reverse process. It says the difference of two squares. If you have something that's in the difference of two squares, the way that you factor it is what? F plus L, F minus L. Okay. It's the reverse. It just goes. It's the reverse process. Goes that way. Okay. So how do you know if you have something of the format of a difference of two squares? You're looking for two terms with a minus sign in the middle, and the two terms are what we call perfect squares. Perfect squares. How do you know if you have perfect squares? What does it mean to be a perfect square? Well, something with an exponent of 2. Y squared, x squared, m squared. Something with an exponent of 2. The trick is usually in that last one. Okay? So something like 9. How do I know that 9 is a perfect square? Well, a number is a perfect square if it can be factored, if its factor repeats. So instead of memorize, so what I do when I was doing this is I just make myself a list. Remember, I made a list one time of prime numbers, 2, 3, 5, 7, 11, 13. I don't remember them. I just want to know what they are. So I made myself a list, 2, 3, 5, 7, 11, 13, things like that. Make yourself a list of perfect squares, okay? What are a list of perfect squares and how do you construct them? There's a way to construct them. So a perfect square is a number that when you multiply it with itself, okay, its factor repeats. So 1's a perfect square. 2 times 2 gives me what? 4. 4's a perfect square. 3 times 3. 9's a perfect square. So basically you're looking for these things where if you take a number, multiply it with itself, what you get is a perfect square. 4 times 4, 16, perfect square. 5 times 5, 25. 6 times 6, 36. So you can construct perfect squares by taking a number and multiplying with itself. The product of multiplication is the perfect square. So what you're looking for is this value right here to be one of those perfect squares. 1, 4, 9, 16, 25, 36, whatever it is. And so what you do then, what you do, if you see that what you have are perfect squares, whoops, if you see what you have is two terms, both of them are perfect squares with a minus sign between them, that's the difference of two squares method. That's what this says. Two terms, both perfect squares, minus sign in between. If you have that circumstance, what you do is write the first term as a perfect as f squared, okay? So it already is here. How would I write the 9? I would write it as, somebody said it?
3 squared?
3 squared. Write it as that value. So 3 squared. So this is going to be my f value. This is going to be my L value. And I come up here to my pattern. Okay? And so how am I going to write it? Y plus 3
Y minus.
minus 3. Boom. That's it. It's just recognizing the pattern. That's the key to the whole thing. So difference of two squares, and let the name guide you. Difference, subtraction, two terms, both of them perfect squares. Difference of two squares. We actually did, you don't realize it, but we actually did all the lesson, all those lessons real quick. So if you need to take another day, we're going to do this again. We're going to review this on Monday too. So let me switch over then, because we're kind of right at the end, and I don't want to keep you. I don't want to take that time. Where are we at? Boom, right here. Okay. So what's coming due on Sunday? We did this tonight. That's the factoring, the trinomials, the three terms, the trinomials. And we did this one here and this one here. Okay. Now the cool thing is, this is nothing but the distributive property, or the FOIL method, if you want. Okay. You can still apply that. You don't need those patterns at all. You just need to know how to multiply binomials. That's it. This one here, the main takeaway is the difference of two squares, because that's something that's unlike anything else. Okay. F squared minus f squared L squared gives us f plus L times f minus L. Okay. That's the difference of two squares method. Okay. There's another special technique, but you don't need it because you learned how to do these. The other special technique is already encompassed by those two right there. It's sort of almost a waste. I don't know why they do that. In algebra, I'm not saying SLCC or whoever I got this from. It's just in general, it's sort of redundant. It's repetitive. And let me show you what the example is real quick. It'll be real quick. Oops. Hold on. My screen went away. Let me go back here. Okay, let me go to another page. Let me do this. Oh, wait, do I have it? No. Wait, let me just do a new page. Okay. So one of the things we did is, remember this one? 2x squared plus 4. Actually, let me do this. We took this one and we multiplied it together to get, that was one of the first ones we did. Well, what they're going to do is they're going to do the reverse process, okay? X squared plus 2x plus 1. They're going to give you a trinomial that's called, and this is what it's called, a perfect square trinomial. Trinomial, okay? They're going to give you this pattern and say, hey, why don't you apply this pattern? And you can say, no, thank you. I already know how to do this one because this perfect square trinomial factors how? Just like we did in the first part of it. It's what's the leading coefficient?
1.
1. So we can do what? Write two sets of empty parentheses, put the x in the middle, in the front, find the factors of the c term that add to give us the middle term. Oh, well, what are the factors of 1? 1 times 1, or negative 1 times negative 1? Which one adds to middle value of 2?
One.
1
Yeah.
and plus 1. So the point is, let me switch back over. When they talk about, in this one right here, special techniques for factoring, and they're going to give you a perfect square trinomial, you can say, no thank you. I already know how to do it because I did these. It's the same thing. So there are some of them that are pattern based, but you don't need to worry about the pattern. What I'm saying is that's why I did this one first, is because why learn something? I'm very much like Jana. Why learn something, a new rule, when an old rule already covers it? So you can take your skills. So what I recommend you do, if you're looking for an order to go in, I would recommend doing what you should. Hopefully you've done it. So do this one first, do this one second, uh, then go ahead and do this one. Yeah, actually you should. Yes. Do this one third, do this one fourth. Where are we at now? And the others don't matter at this point. So you could say fifth, sixth, seventh. That's how I would do the order, because that's the way we did it when I taught it, when I presented it here. But actually, that's the presentation of the skills that you need in order to do each one. Because if you go in that order, when you get over here, you're going to be like, oh yeah, I know this stuff already. You've done it in the other ones, and same thing here. When you get right here, you'll say, I already did that. I did that right there. And in fact, maybe we just switch it up. Sixth, seventh. If you're looking for a recommendation, you can go down the list. It's fine too, because we presented it here. But I think if you go in that order, um, you set yourself up for, I think, moving. You set yourself up for moving more quickly through the lessons by doing it that way. So even though it says the due date here is Friday, October 11th, don't worry about that. Your goal is to have all of this done, to have all of these completed by Sunday, Monday. Kind of, it's fluid. I'm not it all goes together. And so we just put due dates to have due dates sometimes. Okay. So it feels like a lot tonight. And I'm not saying it's not a lot, but the cool part about it is it all goes together. And so by talking about one, we actually get to talk about a lot of them all together. And that's why I did it, is as one big lesson. We're going to review again. So if you don't get through all of this by Sunday, that's okay. Have a goal for Monday. Okay. That's probably what I would say. Because then we're going to probably look at, um, ooh, wow. Anyways, we're probably going to look at doing a review that night, and then we're going to start our next lesson, our next chunk of material on functions. But the cool part about that is it kind of wraps right back into this. So you're going to have this is going to give you a good base. Okay, that's it for me. I've kept you 6 minutes over, and I apologize for that. Let me pause. Any questions on any of this?
So you will be going over the FNL method Monday, right?
I'll review it again, yes. But I think if you go through Hawks, the lesson, I think you're going to find it helpful too. So my point is challenge yourself to work in it in Hawks as well. I'm gonna post this video as well, so you can see it again tonight, over the weekend. Challenge yourself to work with Hawks and see if you can, navigate through, to try to get done. What I'm saying is on Monday I'm going to review it briefly, not the entire hour, hour and a half, but I will review it briefly so that we kind of have a refresher, so that if you don't do it, you kind of can probably have a better shot of finishing by Monday. But challenge yourself. I encourage you to push yourself a little more, because you've gone through the first part of it. This part is not easy either. But my sense from everyone is that you got it. It's just a matter of practice. So push yourself to see how far you can get through all the lessons over the weekend, and I think you'll probably be surprised as to how far you get too. So I'll let you have at it, and shoot me your questions. I have some emails here I need to work through, so I'll be responding to everybody soon. But I'll post that. I'll post the video as well, so you'll see that probably tonight or tomorrow. Okay.
All right. Thank you.
All right. Y'all have a good one.
Have a good weekend.
Let's check the
I
chat.
just wanted to let you know that I did find it. I did end up finding it afterwards, that it was on the other one. I didn't hear you before where you posted it, so
Oh, okay.
I got it.
There you
I'll
go.
go and turn it in today or tomorrow, okay?
Yeah, that's good. That works for me. Appreciate it.
I just wanted to let you know.
Okay. Good. Good.
Did you by any chance check to see if any of my grades went over on the other side, or do you still want me to send them to you regularly?
Keep sending. I think
Okay,
I think there's a
no
glitch.
problem.
Yeah.
Okay, I'll just start sending them to you. I just want to make sure.
Yeah. Hate to do the extra work, but once you get your
No, I'd
grades,
rather do that. I'm making 100s on them. They're not that hard once you start going through them. I just want to make sure that you were getting the grades
yeah,
because I don't have anything on this side. So, all
you
right.
got to get your
Thank
points.
you.
Okay. Good. All right. Y'all have a good one.
Bye.